In this video, we got 4 quadratics here, and we're going to have to graph each of them, state the vertex, axis of symmetry, direction of opening, and the domain and range. Starting off here, let's write number 1. Y is equal to 1/2 x minus 3 squared minus 1. So notice that this quadratic here, it is in vertex form. So what's the vertex? We could tell right away it's positive 3 and negative 1. Okay? It's always the opposite sign here and then the same sign. So x value, y value, that is the vertex of the parabola. What's the direction of opening? Well, notice the a value is positive. If the a value is positive, it means the direction is up. So it's a parabola that's going to open up because that a value is positive, that a value 1/2. If it was negative, then it'd be opening down. What's the axis of symmetry? Well, the axis of symmetry in general, it's always x equals the x value of the vertex. It's basically a line that cuts the parabola in half, and it's always going to be the x value of that vertex. So the x value of the vertex here is 3. So we know the axis of symmetry is x is equal to 3. And then domain and range, and then we have to graph it as well. So let's do that after. Let's state the domain and range after we graph it. Now, if this is in vertex form, the way I like to graph it is I like to put the vertex in the middle. So I like to put 3, negative 1 right there. And then I like to pick 2 x values to the left of 3, so 2 and 1. And then 2 values to the right of 3, so 4 and 5. And that's going to make sure that the y values here are nice and symmetric, so it's going to be a nice shape. So if we plug in an x value, or let's just start with an x value of 1 here, we'll have 1 minus 3, negative 2. Negative 2 squared is positive 4. Positive 4 times 1/2 is 2. 2 minus 1 is 1. Here, if we plug in 2, 2 minus 3 is negative 1. Negative 1 squared is 1. 1 times 1/2 is 1/2. 1/2 minus 1 is negative 0.5. If we plug in 4, 4 minus 3 is 1. 1 squared is 1. 1 times 1/2 is 1/2 minus 1. That gives us negative 0.5. Then if we plug in 5, 5 minus 3 is 2 squared 4. 4 times 1/2 is 2. 2 minus 1 gives us 1. Notice it's nice and symmetrical here. So if we take this and actually graph it, so we got 1 and 1, which is like up here. We got 2 and negative 0.5. It's like down here. 3 and negative 1 over here. 4 and negative 0.5 right there. And then 5 and 1 up here. So parabola looks something like this. Right, and that vertex is at 3 and negative 1 right there. Right, so nice and symmetrical. So notice, again, axis of symmetry, x is equal to 3. That's a vertical line. That's cutting it in half. It's just the x value of the vertex. The direction is up. And now from here, what's the domain and range for this parabola here? Well, the domain for a parabola is always XCR, unless it's a word problem. If it's just an abstract parabola, XCR always. The x values can be anything because this keeps going on forever. The range depends on 2 things, though. It depends on whether it's opening up or down and the y value of the vertex. So notice that it's opening up, and what's the y value of the vertex? It's negative 1. So all the y values are going to be greater than or equal to negative 1. Now, if it was opening down, then all the y values would be less than or equal to -1. So this is always the range, YER, and then y is either greater than and equal to or less than or equal to the y value of the vertex, depending on if it's opening up or down. So that is the answer for number 1. Moving on to number 2, we got y is equal to -2x² plus 5. So whenever you get something like this, y is equal to ax² plus c in general, right? Notice there's no bx, so there's no constant with just an x attached. You just got the you got the ax squared, this -2x², and then you got the c, this 5 here. Whenever you get something in this format, the vertex is always going to be 0 and the c value. Always. So the reason why is we could actually rewrite this as x plus 0 squared plus c. Right? X value of the vertex 0, y value of the vertex is c. So this -2x² plus 5, we can rewrite it as x plus 0 squared plus 5. So the vertex is 0 and 5. So you may just want to make a note. Whenever it's in that format, ax² plus c, there's no bx in the middle, the vertex is always just 0 and the c value. Okay, so -2x² plus 5. So we know the vertex is 0 and 5. What's the direction of the opening? Well, notice the a value is negative. So because the a value is negative, the direction is down. What's the axis of symmetry? It's always x equals the x value of the vertex. The x value of the vertex in this case is 0. So that's the axis of symmetry for this parabola here. Now, if you want to graph it, what I would do is I'd make a table of values, and I would put the vertex in the middle. So 0 and 5 goes in the middle. And then you want to pick two x values to the left of 0. So -1, -2. And then two x values to the right of 0. So 1 and 2. So if I plug in -1 here, -1 squared is 1 times -2 is -2 plus 5. That gives us 3. And here, -2 squared is 4. 4 times -2 is -8 plus 5 gives us -3. And then plugging in 1 here, 1 squared is 1 times -2. -2 plus 5 gives us 3. Plugging in 2 here, 2 squared, 4 times -2, -8 plus 5 gives us -3. And notice that it is symmetrical because we put that vertex in the middle and then pick two x values to the left, two x values to the right. So if we take these here and we graph them, -2 and -3, that's like down here. -2 and -3 is down here. -1 and +3, that's like over here. 0 and 5, that's up here. 1 and 3, that's here. And then 2 and -3, that's down here. So that's how the parabola looks when the vertex is at 0 and 5. Axis of symmetry is x is equal to 0. It's cutting the parabola right in half. And then from here, we can get the domain and range. So domain is what? XER, right? X can be anything. That's always the domain for a parabola. The range is YER, but y has to be what? Less than or equal to 5. All the y values are less than or equal to 5 because the parabola is opening down and the y value of the vertex is 5. So that is the domain and range, and there is your graph. Moving on to number 3, we got y is equal to -4 bracket x plus 2 bracket x minus 4. So notice that this quadratic is different than these two because this one here is in factored form. And when a quadratic is given in factored form, what's easiest to get is the x-intercepts. So the x-intercepts you get from the factors. So x minus 4, that would give us an x-intercept of positive 4. And then x plus 2, that would give us an x-intercept of negative 2. Like that. So in this case, finding the vertex is a little bit different. So the way you want to do it, so let's do a bottom note here. First, we're going to find the x value of the vertex. And the way you do that is you take the two x-intercepts, add them up, and divide it by 2. So 4 plus negative 2 divided by 2. So then 4 plus negative 2 gives us 2, divided by 2 gives us 1. X value 1. So the vertex, the x value of the vertex is 1. Right? And that makes sense because 1 is right in the middle of the intercepts. And a quadratic, a parabola, is always symmetrical. So for example, if we have this is the x-intercept, this is the x-intercept. The middle is right there, which is the x value of the vertex. Right? So the middle of the intercepts is always going to be the x value of the vertex. And now, for the vertex, we can calculate the y value. How do we do that? Well, we would just plug in an x value 1 into x, into the actual function. So 1 plus 2, and then 1 minus 4. So negative 4 times 3 gives us negative 12, times negative 3 gives us positive 36. Let me just double check that. Negative 4 times 3 is negative 12, times negative 3 gives us positive 36. 1 and 36, so the vertex is actually up here. The coordinate is 1 and 36. So those are the steps to find the vertex when you're given a quadratic in factored form. Once it's given in vertex form, you can get the vertex right away. In this case, you got to do a little bit more work to get the vertex, but you do get the intercepts, which is nice. You can get them right away from the factors. So this is just going to open down and go through the intercepts. I'll erase this here. Right? So that's how the parabola looks. You don't even have to make a table. I usually don't make a table if I'm given it in factored form because all I need really is the x-intercepts, then the vertex, and then you can just draw the parabola. So notice the direction of this, it's opening down. And we could tell because the a value is negative. It's negative 4 here. That's the a value of the factored form. Axis of symmetry is always what? X is equal to the x value of the vertex, which is 1. Right? It's going to cut it in half right there. And then from here, we can get the domain and range pretty easily. Domain is always what? XER. The range is YER. Y has to be less than or equal to 36, the Y value of the vertex. And yeah, that's it. So if you're given it in factor form, you don't really have to make a table of values. You can if you want. If I was to make a table of values, I would put the intercepts at the end. So I'd have negative 2 here, positive 4 here, then we'd have negative 1, 0, 1, 2, 3. Right? And then you could plug these into here, and then you'd get something nice and symmetrical. And then notice that the 1, x value 1, that would give us a y value of 36. That's like right in the middle in the table, which makes sense because the table would be symmetrical. But again, if it's given in factored form, I usually don't make a table. I more so make a table if I'm given it either in vertex form, in standard form, like these. I get the vertex first, and then I make a table that's symmetrical. But yeah, that is the answer for number 3. And then finally, number 4, we got y is equal to negative 2x squared plus 4x minus 1. In my opinion, out of all of these, is the toughest one. Because standard form, it doesn't give us any information. Here this was in standard form, but it was a specific case because there was no b value. But in this case we have a b value, right? So it's in standard form. It's hard to get any real information from this. Can't get the vertex right away, can't get the intercepts right away. We can get the y-intercept, which is -1. If we plug in x value 0, these go away, just left with -1, but that doesn't give us too much. It's always better to have the x-intercepts or the vertex. So multiple things you could do. You could find the x-intercepts if you want. You could factor this. Actually, I don't think it factors, so you'd have to put these in the quadratic formula to get the x-intercepts. They would be decimals. Another thing you could do is you can complete the square. So I'll do a little review from grade 10 of completing the square. And when we complete the square, we're taking standard form and converting it into vertex form. So then we get the vertex right away, which is nice. So what you do is you factor out the constant here from the first two. So take out -2, then we'd have x squared minus 2x. And this would be -1, like that. And then what we can do here is we take the -2, divide it by 2, and then square it. So -2 divided by 2 is -1, squared is 1. So +1 minus 1, -1 like that. Then we take out the -1. If we take it out of the bracket, we've got to multiply it by what's in front. So rewrite these three terms, but -1 times -2 gives us +2, subtract 1. Then -2, this here factors into x minus 1 squared. 2 minus 1 gives us +1, like that. Right? So, erasing all this here, basically this is the same as this. Right? If you were to expand this, collect like terms, simplify, you would end up with that standard form. But now it is a lot nicer because we have it in vertex form. So what's the vertex? +1 and +1. What's the direction of the opening? A value is negative, so it's opening down. Axis of symmetry is the x value of the vertex. X is equal to 1. That's the line that's going to cut it in half. And if you want to graph this, I would put the vertex in the middle, pick two x values to the left, so 0 and -1, and then to the right, 2 and 3. Now these x values, to get the corresponding y values, you can plug it in either here, or you could plug it in up there. So if I take 0, plug it in here, 0 minus 1 is -1, -1 squared is 1 times -2. -2 plus 1 gives us -1. Then -1 minus 1 gives us -2, squared is 4. 4 times -2 is -8, plus 1 gives us -7. Same thing, 2 minus 1 is 1, squared is 1, -2 times 1 is -2, plus 1 gives us -1. 3 minus 1, 2 squared, -8 plus 1, -7. Notice how it's nice and symmetrical. And then you could take this and graph it. So -1, -7 down here. 0, -1 is here. We got 1 and 1, which is up here. Then we got 2 and -1 down here. 3, -7 down there. Right? Should be a nicer shape, but that's how it looks like. The vertex is at 1 and 1. Then from the graph, what's the domain? What is the range? Domain is always XER. Range is YER, but in this case, Y has to be less than or equal to the Y value of the vertex, +1. All the Y values have to be less than 1. Less than or equal to 1, rather. And yeah, that's it. So number 4, in my opinion, is the toughest because we had to complete the square. Another thing you can do, as I mentioned, you could put in the quadratic formula and get these intercepts. They would be decimals. But then adding them divided by 2, you would get 1. You would get that x value of 1 right in the middle. But yeah, either way works. But completing the square, finding the intercepts of quadratics, we're going to do more examples of that in future sections, but thought I would just throw this one here in this section just to get you a little warmed up.